In this lesson, we're going to go through ionic compounds, and we're going to go through a couple of examples putting together ionic formulas. So ionic compounds are molecules that consist of ions with opposite charges. Electrons are transferred from the cation to the anion. Ionic compounds are neutral. So let's take a look at our periodic table here. If you recall, elements that have group 1A, 2A, and 3A, they're going to lose electrons. So everything in group 1A will have a charge of +1 because it's losing one valence electron. Everything in group 2A is going to have a charge of +2 because it's losing 2 valence electrons. And then everything in group 3A is going to have a charge of +3 because it's losing 3 valence electrons. Okay, now groups 5A, 6A, 7A are going to gain electrons. We want to have a full valence shell. 5A is only 3 away from having 8, so it's going to gain 3. It'll have a charge of -3. Group 6A is 2 away, so it'll gain 2 to get to 8. And then group 7A will gain 1 to get to 8, so it'll have a charge of -1. So essentially what's going to happen in ionic compounds or in ionic bonding is we're going to have something from the cation side, something with a positive charge, is going to bond with something with a negative charge. Okay, and then when we say that they're neutral, the amount of positive and the amount of negative should cancel out, and you'll end up with a neutral compound. So let's look at an example. It says model the formation of the anionic compound between sodium, Na, and chlorine, Cl. Let's start by drawing our Lewis dot diagrams. So we've got sodium, Na, okay, and it's got one dot, it's in group 1. And then we have chlorine. So chlorine is in group 7A, so it's going to have 7 dots. So 1, 2, 3, 4, 5, 6, 7. Okay, so we've got a positive, we've got a negative, and what's going to happen in these ionic compounds, sodium has an extra valence electron it wants to get rid of. Chlorine has 7 valence electrons. It needs 1 more to be happy, so sodium is going to donate this electron over here. So the arrow is what represents the transfer of electrons. The arrow is always going to go from cation to anion. Remember, the cation is positive to anion. Okay, so we've got that. Next, what we're going to do is we're going to draw out our ions. So sodium is losing electrons. So sodium is going to end up with a positive charge. And remember, anytime we draw these ions, if they're giving up valence electrons, we're not going to have any dots. Okay, so we've got sodium. It gave up 1 electron, so it's going to have a charge of +1. Chlorine gained that electron, so when we gain, we want to have all 8 dots. 2, 3, 4, 5, 6, 7, 8. And it gained 1, so it's going to have a charge of -1. So our formula here for our compound is going to be NaCl. couple things to remember when we write out our formula. The cation always comes first. And then if we have to add multiple ions, which you'll see in some of these later examples, we want to add subscripts to indicate the number of each ion needed. All right, let's look at another example. So in this example, it says model the formation of the ionic compound between fluorine and magnesium. Okay, so we've got fluorine and magnesium. Well, magnesium, Mg, magnesium's in group 2, so it has 2 valence electrons, 1, 2. And then we have fluorine. Fluorine is in group 7. It has 7 valence electrons. Okay, so just like before, let's go ahead and let's draw our arrow from cation to anion. Okay, that's great. Magnesium gave up its one of the 2 valence electrons, but the problem is we still have another valence electron that we need to give away. So in this situation, what we're going to do is we're going to add another fluorine. And again, fluorine has 7 valence electrons. So magnesium has 1 more to give away. So look, we can make another fluorine happy. So let's go ahead and draw out our ions. So we have magnesium. Magnesium gave away its valence electrons. It gave away 2, so it's going to have a charge of +2. And then fluorine gained. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it gained 1, so it's going to have a charge of -1. But we want to write this out for each one. So we have fluorine again. 1, 2, 3, 4, 5, 6, 7, 8, and -1. Okay, so if you recall, one of the last things that we wrote about formula writing was we add subscripts to indicate the number of each ion needed. So in this case, we have 2 fluorines that we needed. So our formula that's totally my cat right now. Our formula is going to be magnesium, cation goes first, Mg. And then we have fluorine. But because we had 2 of them, we're going to add a subscript 2 here. So our formula will be MgF2. All right, let's look at one more example. All right, this example says model the formation of the ionic compound between lithium and oxygen. Okay, so we've got lithium. Lithium has 1 valence electron. It's in group 1. And then we have oxygen. Oxygen has 6. So we go from cation to anion. So lithium will give its valence electron to oxygen, but lithium's cool. Lithium gave away its 1 valence electron, but oxygen, not so much. Oxygen still only has 7. It needs 1 more. So we're going to add another lithium here. Okay, so lithium has 1, and lithium will give that away to oxygen here. So let's go ahead and write out our ions. So lithium gave away its valence electron, so it'll be lithium, no dots, +1, because it gave away. And then same thing on this side, we've got lithium, +1. Oxygen in the middle has 8 dots. Okay, oxygen gained 2 valence electrons, so it'll have a charge of -2. And then when we write out our formula, it's going to be cation first. So we had 2 lithiums, so it's going to be Li, and then we have 2 valence electrons, or sorry, not 2 valence electrons, we have 2 lithiums, and then we have 1 oxygen. So our formula will be Li2O. All right, let's look at another example. In this example, it says, write the ionic formula for, we have magnesium and sulfur. So what we're going to do this time is we're going to kind of skip writing out or drawing out our Lewis structures. We're going to jump right into putting this together. So magnesium. If we go to our periodic table, magnesium is in group 2, so it's going to have a charge of +2 when it ionizes. And then we have sulfur. Sulfur is in group 6. It has a charge of -2. It needs 2 more valence electrons to get to that 8. So if we look at the 2 charges, we have +2, we have -2. We don't need to do multiples of anything. We can just take these 2 pieces and put them together. So this will be magnesium and sulfur. Put them together just like that, MgS. Okay, so our steps to working through these, just write a couple steps down here. So step 1, we're going to determine the charge of each ion. Okay, step 2, determine the ratio needed to make the compound neutral. Okay, so we looked at the charges. That was our first step. In this case, it was a 1-to-1 ratio. We needed 1 magnesium for every sulfur to cancel out and end up with the neutral compound. But as you'll see in our next example, it's not always that easy, but not too terribly difficult. Okay, so in this case, we have aluminum and bromine. So aluminum is in group 3, so it's got 3 valence electrons. It's going to lose those. It'll have a charge of +3. And then we have bromine. Bromine is in group 7. It needs 1 more valence electron, so it's going to have a charge of -1. Okay, so we've determined our charges. Now, in order to cancel this out, we're going to need 3 bromines, each with a charge of -1, to cancel out with our aluminum, which has a charge of +3. So when we write our formula, it's going to be Al, and then we're going to have bromine, and then we'll just tack on that 3 at the end here, because we needed 3 bromines to end up with a neutral compound. All right, let's do another one. Okay, how about potassium and oxygen? Okay, so potassium is in group 1, so it's got a charge of +1. Oxygen is in group 6. It has a charge of +2. So if you look at this, we need 1 more potassium to cancel out. Oops, just realized I wrote +2. That should be -2. Okay, so we need 2 potassiums to cancel out with our oxygen. So our formula will be K, and then we're going to need to add a 2 here because we had 2 potassiums, and then O, so K2O. It's like H2O except cooler because, you know, it starts with a K. All right, let's do another example. All right, let's look at calcium and phosphorus. So calcium is in group 2. So it's going to have 2 valence electrons. When it loses those, it will end up with a charge of +2. And then phosphorus Phosphorus is in group 5. Phosphorus is going to have a charge of +3 because it needs 3 more valence electrons. And oh boy, well, I can't multiply calcium, so I can't keep adding calciums and have it turn into a number that will cancel out with phosphorus. So like 2 times 1 is 2, that doesn't cancel with 3. 2 times 2 is 4, that doesn't cancel with 3. Same thing with phosphorus. Okay, phosphorus, I can't multiply 3 and have it come up to a number that is 2. So we're going to have to multiply each of these. So an easy way, the easiest way to do this is to just multiply our 2 exponents here, our 2 charges. So 2 and 3, we want to get to a common number of 6. So to do that, I'm going to need 3 calciums and 2 phosphoruses. And I keep writing +3. This is supposed to be -3. Okay, so we've got 3 calciums, and then phosphorus, we have 2 of those. Tell me this isn't the most fun you've ever had watching a video. Okay, let's look at something different. It says predict the charge of the cation. Copper Cl2? What? Copper? Wait a second. Copper is in the forbidden area of the periodic table. Copper is right here. And I'm pretty sure that we were told to kind of like pretend like this middle part of the periodic table didn't exist. Well, this is where that kind of comes into play. So let's go back and let's look at that example. Cat is very interested in chemistry right now because we're talking about cations. Get it? Cations and cats. It wasn't very funny. Okay, so copper, Cu, is going to be our cation, but we don't know what its charge is. Okay, so I'll just put an X up here. We don't know what it is. All right, and then we have chlorine. Okay, there's 2 of them. And we know that chlorine has a charge of -1. So total, we have a charge of -2. And since this is an ionic compound, they're neutral. So we want our positive to cancel out with our negative. So we need a total charge of +2. Since there's only one copper, this has to be +2. Okay. So the ion here will be copper with a +2 charge. All right, let's take a look at this example here. So we have iron, Fe2, and then we have O3. Okay, so again, let's find iron. Okay, iron is here. It's in that middle part of the periodic table, so it's going to have a variable charge. We have to look at what it's attached to figure out what its charge is. So we've got iron and iron. We don't know what the charge is. And then we have oxygen. We have 3 of them. Oxygen has a charge of -2 because it's in group 6. Okay, so -2, -2, -2, that gives me a total of -6. Okay, and then we have, let's see, we have 2 X's. We don't know what X is. Okay, so we'll do a little bit of algebra here. So okay, so we want this to cancel out, so we want it to be a +6. So let's divide both sides by 2. So X equals 3. So the charge on each one of our irons needs to be a +3. So the charge on our iron will be Fe +3. All right, one more example. Okay, here we go. So we've got lead, and then oxygen. So let's find lead. So on our periodic table, lead Pb is down here. Okay. So even though lead isn't in that mysterious like middle section of the periodic table, lead can have different charges. So let's take a look at this one. Okay, so we have lead, Pb. We don't know what the charge is. And then we have oxygen. Oxygen has a charge of -2. There's 2 of them. So just like before, let's add up our negatives. That gives us -4. We know it has to cancel out. So we know that this has to be a +4. Well, since there's only one lead, our charge on this lead is going to be +4. So the answer here is Pb +4. Okay, so if you want to add some steps to your notes, step 1 is going to be start with the anion. So we started with oxygen. We figured out its charge because we have to kind of work backwards. Step 2 is determine the charge of the anion. Step 3, use the formula and change the anion to figure out the charge of the cation. So kind of the algebra that we did earlier. The cat is actually translating what I'm writing, but into cat. To figure out the charge. And finally, our last step is charge of the cation. And step 4 is remember ionic compounds are neutral. So our last step is we want to make sure that these cancel out. Okay, and that is how you work with ionic compounds. So much fun. All right, good luck and have fun working on the practice for these.